Let's look at today's notes over solving equations with special solutions. So there are times when your variable disappears when you're solving an equation and you are left with only constants. Now, what is a constant? It's just a number that's all by itself, like +4 or -3. Those are constants. There's no variable attached to it. So the first possible solution that you can get, why won't this erase for me? The first possible solution that you can get is, here we go, is infinitely many solutions. So we have this symbol right here. It's the infinity symbol. And we use it, we can just, this is one of the things I love about math is there's shorthand, there's symbols. We don't have to write infinitely many. There are infinitely many solutions. That means all real numbers. There's this symbol right here, all real numbers. This is true for all values of the variable. That means every number works. Every single number is a solution. So our symbols, let's look at what those are. This infinity symbol is just a sideways 8. That's one answer that you can write. You can write the symbol, you can write infinitely many. You can write this fancy schmancy R. It's just 2 lines like that, and then a fancy R. It means all real numbers. So you can write that symbol, or you can write all real numbers. Anything you want. So let's look at our first example where we will end up getting infinitely many solutions. So I'm going to draw a line down my equal sign, and you don't have to do that. I just like my equal sign to be lined up, and so I like to do this in Algebra 1. I don't use the line in Algebra 2. And I'm going to distribute this 6 into every term on the inside of these parentheses to get rid of these parentheses. So I get 12x plus 6 plus 3. And then what do I do at this point? I'm going to combine like terms. So I'm going to identify these two like terms, and then I'm going to combine them to get 9. And I've simplified the left side of the equal sign as much as I possibly can. So now I'm going to move to the right side. And I'm going to distribute this -3 into every term on the inside of the parentheses. And I get 15x plus 9 minus 3x. And then I'm going to combine like terms over here. 15x minus 3x is 12x. And I get 12x plus 9. Do you notice anything at this point? I have the exact same thing on both sides of the equal sign, so some of you might be able to recognize at this point, I have the same exact thing on both sides of the equal sign. That's infinitely many solutions. But what I want to show you is if I continue to solve the way you know how, well, 12x minus x on the right side cancels out, I'm left with 9. 12x minus 12x on the left side cancels out, I'm left with 9. When you get rid of your variables and you end up with a statement that is true, your answer is infinitely many solutions or all real numbers, or you can write it out. But that's what you get. So let's go to our second example that you'll get infinitely many solutions when you solve it like this. So again, I'm going to draw a line down my equal sign. And I don't have any parentheses on the left side, so I'm just going to combine like terms. So I'm going to combine -2 and +7 to get +5. And then on the right side, I have to distribute this 5 into these terms and this 2 into these terms. So let's do all of that. -15x minus 5. Then when I distribute the 2, plus 8x plus 10. And then at this point, what do I need to do on the right side of my equation? I need to combine like terms. -15x and +8x is -7x. -5 and +10 is +5. So again, we can see that I have the same thing on the left that I do on the right. These are special solutions. These are special cases. That doesn't mean every answer is going to be infinitely many solutions or no solution, which we'll get to in a minute. It just happens sometimes. And it happens when we get rid of our variables. -7x plus 7x on the right side cancels. I'm left with 5. -7x plus 7x on the left side cancels. I'm left with 5. What do you know? Okay, we got rid of our variables. We ended up with a statement that is true. Therefore, my answer is infinitely many, or all real numbers. So let's move on to the other type of solution that you might see. And that is this circle with a line through it. And that means no solution or empty set. Okay, there's nothing in that set. Empty set. This is true for 0 values of the variable. It has no solutions. Okay, so one of the things that I really want to point out is this does not equal 0. Okay, do not try to put a circle with a line through it and have that equal 0. X equals, it does not equal 0. So make sure you don't start doing that. It means no solution, okay? That is not the same, okay? So let's see some examples of what this looks like. So when I go down here, okay, this is a no solution example. I'm going to solve it the same way, okay? It's just a multi-step equation, so I need to distribute this 1/2 to get rid of my parentheses. 1/2 times 10x, I'm going to take half of it. What is that? 5x. 1/2 times 4, I'm going to take half of it. What is that? It's 2. And then now I'm going to combine like terms. So I need to identify my like terms. I get 3x plus 2. And we're done simplifying the left side of our equal sign. And now I'm going to distribute this 3 into every term on the right side. And I get 6x minus 3 minus 3x. And then again, I'm going to identify and combine like terms. So I get 3x minus 3. So do you notice anything at this point? They're kind of the same, but they're not exactly the same. So let's go ahead and take it to the next step by moving our variables to one side. And 3x minus 3x is 0, so that cancels. I'm left with negative 3 on the right. 3x minus 3x on the left cancels, and I'm left with 2. So in a situation like this, when I get rid of my variables, but I end up with a statement that is not true, 2 does not equal 3. When I put a line through that equal sign, that does not equal 2. Okay? This is not a true statement. That means there is no value that I could plug in for x that would make this equation true. There's no value out there when I plug in that same value for x for everywhere you see an x in this equation, you will never get the left side equal to the right side. It won't happen. There's no solution. So let's move on to the next example where you'll see the same thing happen. So I'm going to draw a line down my equal sign, and I'm going to distribute this negative 7 into every term on the inside of the parentheses. I get negative 21x minus 14 minus 6. When I combine like terms here, I get negative 21x minus 20. So now let's do this on the right side. I'm going to distribute this 6 into every term, and I get negative 24x plus 18 plus 3x plus 6. I don't know why my computer's doing that. Okay, so now we're going to combine like terms, negative 24x plus 3x. So when I combine those different signs, subtract, we're going to get negative 21x. And then I've got 18 plus 6. And what is that? It's 24. So you may notice that you have the same coefficient with the variable on both sides, but you don't have the same constant. So let's continue and take it a step further. So now I'm going to add 21x to both sides. They both cancel. I'm left with negative 20 equals 24. But is that a true statement? No, I've gotten rid of my variables. Negative 20 does not equal 24. Not true. Therefore, my answer is no solution. Okay, so these are just special solutions. I have had students where once I show them this, then all of a sudden every answer is no solution or infinitely many solutions. Not the case. You will still have answers where x equals a number. Could be An integer could be a fraction, proper or improper. But then now that you've seen this, you could have answers that are infinitely many solutions or no solution. So that concludes our notes over solving equations with special solutions. I hope it was helpful.